8.6 then. We're starting out with rational equations. Carter, would you mind just closing the door, please? And as I said, so rational equations and inequalities. Rational equations are equations that would contain one or more rational expressions. So you see fractions within the equation. The denominators could include variables. We have solved equations, or you have solved equations before, even before this year, that involved fractions. And I know one method I showed you, if it wasn't showed to you previously in previous math classes, is whenever you have an equation that contains fractions, it's often easiest to eliminate the fractions first. And to eliminate the fractions, you multiply each side by the least common denominator, the LCD. So we learned in 8.2 how to combine sums or differences of fractions by finding a least common denominator. You did that on your quiz. Or if that was something that you struggled with, this is going to kind of review how to find a least common denominator. And then we multiply both sides by the least common denominator, solve the resulting equation, check your solutions, make sure they actually work in the original equation, and that's how you would find your answers. So I have two examples of rational equations. They both, between the two, although the overall process is the same, they work out a little differently. So for the first one, your first step in looking at these equations is to look at your denominators and determine what the least common denominator is. So if we have denominators of x plus 3, and you could, if it helps you, put parentheses around the x plus 3. So we have x plus 3, 2, and then 10 as our three denominators. Any ideas on what the least common denominator would be for those three expressions? Not 30x. I think that's what I heard. Wouldn't just be 30. Because it's not, you're not looking at 10, 2, and 3, because the 3 is being added to the x. So the x plus 3 is all one quantity. So if you were to make all three of those denominators the same, what would you make the three denominators? You wouldn't make them all 30. 10, so 10, the 2 and the 10, the least common multiple would be 10. And then what else needs to be included? The x plus 3. Okay, so the 10, because again of the 2 and the 10 here, this 3 is part of this quantity, and that's all part of your least common denominator. So 10 times the quantity, x plus 3 is your least common denominator. So then what we're going to do, and however you want to write this out is up to you. I'm going to kind of spread things out so you can see exactly what I'm doing. But I am going to multiply every single fraction. You're multiplying both sides of your equation, but that means you're multiplying every single term by the least common denominator. So I'm multiplying, if I have 2 over x plus 3, that is, I could put a parenthesis there, that is being multiplied by the least common denominator. And if it helps to make this a fraction, you can put it over 1. So it's being multiplied by 10 times x plus 3 over 1. And then I still have the plus 3 over 2. That is also getting multiplied by the least common denominator. And then equals the 19 tenths is also getting multiplied by the least common denominator. So I'm just writing it out this way so you can more easily see it. If you can kind of squeeze it into the original equation and just say everything's being multiplied by 10 times x plus 3, however you write it is up to you. I just want you to see what I'm doing. So what I have in blue is the original equation. I'm just showing everything gets multiplied by that least common denominator. Okay, so then, because you found the least common denominator, remember that when you multiply fractions together, you can cross-simplify. And I would recommend doing that because when you cross-simplify, what should happen is all of your denominators should cancel out to be 1s. So for example, when I multiply the first fraction by 10 times x plus 3, I can cross simplify the x plus 3's, cancel each other out. So that first fraction, the denominator is now just 1, so I don't even need the denominator. And I would just multiply what's left across the top, which is just 2 times 10. So that first fraction now just becomes the number 20. Then I carry down the plus sign. For the next fraction, I can cross simplify the 2 and the 10. So the 2 would cancel to be a 1. The 10 would be divided by 2 is now a 5. And then if I multiply across, I would have 3 times 5, which is 15, and I still have the quantity x plus 3. But my denominator is just 1, so I no longer have a fraction. And then I have equals. For the last fraction, cross simplifying, the 10s cancel each other out and both just become 1s. So then multiplying across, I still have the 19 times the quantity x plus 3. So I now have an equation that doesn't include fractions, and then in my opinion is easier to solve. Yes, Cora?
How can you distribute the middle one between the
We will. I'm going to do that in this next step. You could do that right away, though, if you wanted to. So you're talking about this here?
Yeah, like when would be like 15 and then 3 like 100 when you were first multiplying.
Oh, I see what you're saying. When you multiply these, the 3 and if you multiply the 3 by the 5, you don't also distribute the 3 to this. Because it would be as if you're distributing the 3 to this and the 5 to this, but if you multiply the 3 and the 5, you're taking care of that already then by just distributing the 15. So you don't need to also distribute the 3 if you've multiplied it by the 5. Okay, so in the next step to solve this for x then, I'm going to distribute this 15 and the 19 to their x plus 3s. So we have 20 plus 15x plus 15 times 3 is 45 equals 19x plus 19 times 3 is 57. Okay, and then I would probably simplify the left side, just add together the 20 and the 45. So I have 15x plus 65 equals 19x plus 57. And then you know with solving equations, you know, whatever order of steps you do right now, it doesn't matter as long as you're doing the steps correctly, we should get to the same answer. So I would probably subtract 15x from each side. So 65 is equal to 4x plus 57. And then I would subtract 57. So 65 minus 57 is 8. So 8 is equal to 4x, and then divide by 4. So x is equal to 2. Okay, so the new step is getting that least common denominator, multiplying everything by it. From there, solving the equation. You've solved equations since probably before Algebra 1. So any questions just on getting x equals 2? Okay, sometimes, and this is what it says below here, multiplying each side of an equation by a least common denominator when you have rational expressions, so when your least common denominator includes a variable, this can make it so that this equation that you get here after you've eliminated your fractions gives you a solution that's not actually a solution for the original equation. It gives you an extraneous solution. So you should check your answers. And again, I don't need to actually physically see your check. but I'll know if you're giving x equals 2 and it doesn't actually work that you didn't check it. So you should plug it back into the original and just make sure it works. So if I were to check, does x equal 2 actually work out, I would then have this equation. I'd have 2 over, this first denominator would be 2 plus 3. So I would have 2/5 plus 3/2, and I want to know, does that equal 19/10? And this, if you're writing it out, you could add the two fractions on the left side by hand, get a common denominator, add them together. Since I know many of you, if you were just checking on a calculator, just a reminder that you can check fractions on a calculator too. So that on this calculator, if you have a different one and don't know where this is, let me know. But I call it the ABC key. So I could type in 2/5 and then add 3/2. And my calculator gives me 1 and 9/10. Is that the same thing as 19/10? Yes. So then I know it checks out. Therefore, x equals 2 is a solution, or is the solution to that equation. So even if it's just substituting it back in on your calculator, make sure that you check. It's possible that you'll get answers that don't actually work. Okay, and while you're working today, if you have questions regarding your calculator, just let me know. So number 2, this one works out a little differently, so I want to go through this one together as well. Same idea though. So we have this rational equation, looks a little more complicated than the first one. What I would start out doing, so you're still looking for a least common denominator, but if you look at your denominators, the middle one, the x squared plus 8x plus 15, you want to make sure that your denominators are in factored form. So the x plus 5 and the x plus 3 are okay. The x squared plus 8x plus 15 can be factored. So you'd want to factor that before you actually look for your least common denominator. So it's a trinomial. I can set up the diamond. What multiplies to 15 and adds to 8? 5 and 3. So this denominator would really be x plus 5 times x plus 3. So I know the numerator of that fraction as well as a trinomial. You do not have to factor the numerator. I would actually recommend that you don't. But your denominator, before you find a least common denominator, factor the denominators if you need to. So now looking at our 3 denominators, ideas on what the least common denominator would be. Okay, so that first fraction, if you were to get a common denominator, would just need to be multiplied by x plus 3. Last fraction would need to be multiplied by x plus 5. We're not actually getting a common denominator, we're canceling them out, but that is the least common. So now I'm going to rewrite this like I rewrote the first one. Everything gets multiplied by this least common denominator. So I would have 2x over x plus 5. It's multiplied by x plus 5 times x plus 3. And I have minus x squared minus x minus 10 over x plus 5, x plus 3. It's multiplied by x plus 5, x plus 3. And the last fraction also gets multiplied by x plus 5, x plus 3. Okay. So then what should happen, again, is all your denominators should be able to cancel if you cross simplify. So multiplying the first 2 fractions, the x plus 5s would cancel each other out. And what you'd have left is 2x times the quantity x plus 3. And then for the second fraction, since that had the actual least common denominator, both the x plus 5s and the x plus 3s cancel, so that whole thing is just gone. So the numerator is just what it was. What I'm going to do, though, is write that numerator in parentheses because it's being subtracted. So I'm going to put minus, and then in parentheses, x squared minus x minus 10. I'm going to have to make sure to distribute that minus sign to everything. And then equals, for the last fraction, the x plus 3's cancel out. So it's just 3 times the quantity x plus 5. And then from here, we want to simplify this equation. So get rid of the parentheses, distribute. So on the left side, I'll distribute the 2x to the x plus 3. And that's 2x squared plus 6x. And then I do need to distribute. If it helps, you can put, there's really a minus 1 there. So you're distributing a negative 1 to the x squared minus x plus 10, or minus 10. So it becomes minus x squared plus x plus 10. And then equals on the right side, distribute 3 to x plus 5. So 3x plus 15. And then on the left side, I'm going to combine some like terms. So I have 2x squared minus x squared. So I would just have x squared. I have 6x plus x, so plus 7x. And then I have plus 10 equals, and I have 3x plus 15. So now both sides are simplified. In terms of solving this equation, where would you go from here? Might help to identify what type of equation it is. It's a quadratic. So yes, but before you factor or, oh, I don't have it up here anymore, but I can write it up here, or quadratic formula, before you do that, what would we have to do? We can't leave it the way it is right now. Yes, one side has to be 0 before you factor or use quadratic formula. So I would want to, I'm going to leave the x squared where it is. So I'm going to subtract 3x from each side and subtract 15 from each side to get the right side to be 0. So x squared plus 4x minus 5 equals 0. So once you have one side equal to 0, then you can see, does it factor? Can I solve by factoring? Or you could use quadratic formula. Does this one factor? Are there two numbers that multiply to negative 5 and add to 4? Right track. 5 and negative 1. Okay, so we would have x plus 5 times x minus 1 equals 0, and then once it's factored, you'd set both equal to 0. So x plus 5 would equal 0, or x minus 1 would equal 0. So then you would get x equals negative 5, or x equals positive 1. Okay, so we got two answers. You need to check to see, do they actually both work in the original equation? So, again, I'm writing it out. Do I have to see that you wrote it out? No. So I'm going to check negative 5 first. So if I put negative 5 in for x, my first fraction would be 2 times negative 5 on the top, so negative 10, over negative 5 plus 5 on the bottom, which is 0. And then I would have minus, and the second fraction on the top, I would have Negative 5 squared, which is 25, minus negative 5, which would be plus 5, so 25 plus 5 is 30, minus 10 is 20, so 20 on the top. And on the bottom, I'm actually going to look at the factored form. If I put negative 5 in for both of those x's, the first one again would be 0, and then 0 times whatever this one would still be 0. So my denominator would be 0. And then I want to know, does that equal be 3 over, that denominator would be negative 5 plus 3, so negative 2. Any issues with this equation? Okay, yes, the fractions, when you have 0 in a denominator, that is undefined. So I automatically know this doesn't work. So if you plug in a number and it makes any of your denominators 0, it cannot be a solution. Okay, so this would be an extraneous solution. Negative 5 does not actually work out. You still have to check. Don't just say, okay, then 1 must work. It could have no solution. So actually check, does 1 work? So now if I check x equals 1, plugging 1 in is a little bit easier. So the first fraction, I would have 2 times 1, which is 2 over 1 plus 5, which is 6, minus, in the second fraction, 1 squared is 1, 1 minus 1 is 0, 0 minus 10 is negative 10, over, and that denominator, again, I'm looking at the factored form, I would have 1 plus 5, which is 6, times 1 plus 3, which is 4, so 6 times 4, I'd have 24 on the bottom of that fraction. And then does that equal 3 over 1 plus 3 is 4. And again, you could check this in your calculator, type in, let's see, 2 over 6 minus negative 10 over 24. That does equal 3/4. So then I know that 1 checks out. Okay, so the overall process, find the least common denominator, multiply everything by the least common denominator, solve the resulting equation, check your answers. Within that, yes, you might need to review solving quadratics, solving different types of equations. Questions, though, on those two? Okay, the last example then, and then you'll have some time to work and to practice and ask questions if you have them, is solving rational inequalities. So a rational inequality is an inequality that contains one or more rational expressions. And here are the following steps. So inequalities are always a little bit different than just equations. Your first step with an inequality, and we're going to work through this example as I talk through the steps. So the first step is to state the excluded values. And the excluded values are the values for which the denominator is 0. So any values of a variable that would make any of the denominators in your inequality equal to 0. So I'm just going to put a step 1 here. Looking at the inequality, we have an example 3. Are there any values of x that would make any of those denominators equal to 0? Are there any values of x that would make any of those denominators equal to 0? 0. So if one of your denominators is just x, then x can't be 0. And then also 3x, the only way this would be 0 is, again, if you have 3 times 0. 9 is always just going to be 9. So X cannot be 0. That would be an excluded value. Okay, we are going to use that value later in steps 3 and 4. So find any excluded values. You might not have any, but find any excluded values and kind of set them aside. Step 2 then is to solve the related equations. And then you solve this as if it's just an equation and not an inequality. So I'm going to rewrite this with an equal sign. So we're solving 4 over 3x plus 7 over x equals 5 over 9. So this is like how we solved numbers 1 and 2. Find a least common denominator. So if your denominators are 3x, x, and 9, what's the least common denominator? 9x. Okay, so I'm going to multiply. This one's a little bit easier just to kind of squeeze it in here. I'm going to multiply all of these by 9x. You can put 9x over 1 if that helps. You're not multiplying the denominators by anything, just the numerators, but you're cross-simplifying. So that first fraction, I have, if I cross-simplify, I have 3x and 9x. So the x's will cancel out, and the 3 will cancel out. The 9 will be divided by 3, so the 9 would become a 3. So then multiplying across the top, I would just have 4 times 3, so then I would just have 12. The second fraction, the x's cancel out, and so across the top I now just have 7 times 9, so I have 63. And then on the right side of the equal sign, the 9's cancel, but I still have the x, so multiplying across I have 5x. Okay, so on the left side, add 12 and 63, so 75 equals 5x. Solve for x, divide by 5. X is 15. Okay, that's step 2. That's not your answer. Step 3, and we've done this process before with quadratic inequalities. It says use the values determined from the previous step, so that would be the 0 and the 15, to divide a number line into intervals. So I'm now going to take those two values, 0 and 15, and if I were to create a number line, I'd want to just put those two values on the number line, and notice then that it splits that number line into 3 intervals. So you have an interval that is less than 0, you have an interval that is in between 0 and 15, and you have an interval that is greater than 15. And step 4 is to then test a value in each interval to determine which intervals contain values that satisfy the inequality. So you're determining where are the solutions to this inequality, in which of these 3 intervals. Okay, so if I work with the leftmost interval, values less than 0, what is an x value that is less than 0? That would be easy to test, -1. So I'm going to test x equals -1 and see if it works, see if it's true. You're testing it in the original inequality. So I'm plugging in -1 for those x's. So my first fraction would be 4 over 3 times -1. So the denominator would be -3. So that would be a -4/3. And then I would have 7 over -1. That's just -7. And I want to know, is that less than 5/9? Okay, so I could type in, I'm seeing if this is true, type in -4/3 minus 7. That's -8 1/3. Is that smaller than 5/9? Yes, that is smaller. So this is true. So that means I have solutions that are in this interval. Okay, move on to the next interval, so I should test all three. What's an easy number to test that's between 0 and 15? 1. So if I test positive 1, so my first fraction would now be denominator 3 times 1 is 3. So I would have 4/3 plus 7 over 1 is just 7. Is that less than 5/9? So I can reason here if negative 4/3 minus 7 was negative 8 1/3, 4/3 plus 7 is going to be positive 8 1/3. That is not smaller than 5/9. So that is false, meaning I do not have solutions in this interval. Any value between 0 and 15 is not a solution for x. So I have one last interval to check, a number bigger than 15, 16. All right, so my first fraction, my denominator is going to be 3 times 16, which is 48. So I would have 4 over 48 plus the second fraction would be 7 over 16. Is that smaller than 5/9? Okay, so 4 over 48 plus 7 over 16 is 25 over 48. Is it smaller than 5/9? How would you know? You could find the decimals. So I could actually do 25 divided by 48 is about 0.52. 5 divided by 9 is 0.5 repeating. So 0.556, 0.5 repeating. So is this true? Yes, it is smaller, so that's true. Okay, so here's my solution then. So this is not your answer. Don't circle this and say, okay, yeah, I'm done. I mean, you are done, but you have to write your answer. So the x values that are solutions, you're writing your answer as an inequality. I have x values that are smaller than 0, so x values less than 0, or these values are bigger than 15. So I'm using the 0 and the 15 from my values in the previous steps. So also x values bigger than 15 would work. This compound inequality is your solution. So it's not two separate answers. It's the two inequalities joined by or. If you had a solution in the middle, it would be x values between 0 and 15. Cora. A lot of the time it will be for the examples you'll work through. You have denominators like this. For example, in the previous one, if this was an inequality, because like in that first fraction you have x plus 5, so negative 5 would be excluded because that would make that 0. So if you had a denominator like this, you would kind of set it equal to 0, figure out what would make it 0. But a lot of the time 0 will be, yes, the excluded. Not always, but a lot of the time. Okay,